Hey guys, and welcome back to the second Week 6 Hangout. The first one was yesterday, Saturday, but I didn't get the word out well enough, so we decided to have another one a couple hours later today. So we have another good group here. We have Brooke, Bry, we have Josh, Margaret, and Wes is back from yesterday. So I'm excited to talk more about the board. In the meantime, between yesterday and today, I actually managed to get my own MCP 3901 down. I'm sure we'll be talking about that a little bit in terms of how everybody else is doing, and we can go over questions. So why don't we go on down the line, left to right? Brooke, why don't you start and tell us how you're doing?
I'm doing fine. I'm onto the current source part, so I haven't even gotten to the 3901 yet. I got stuck a little bit on the op amp. Since I don't know or understand a lot of this, I really want to learn what's going on. So when I got to the op amp, I was trying to understand the different levels and how I could adjust what my output ended up being. I had to learn a lot about RMS versus VPP and all that. You saw my post.
Mm-hmm.
So that probably ate about a week's time, which was probably supposed to take maybe a day. So I'm on to the current source this week.
Okay, cool. Well, that'll be good. That's good. I think everybody's kind of in different areas. I think if people are past the relay, usually we're in good shape. So that's good. That's good. Brian, how about you? How are things down in Kiwi Land?
Quite good. I haven't done much work on it in the last week. I've been away, but before I went, I got my DAC going, and I put out some example code, and I did some characterization of it and the current source as well, which was quite fun, and the instrumentation amp, which is all on my build log, which was quite good to see all that going for the first time. And now I just have to start tackling the ADC, I guess, and see where that goes. It wasn't as challenging as I thought it would be to get that ADC down, so it's a fun little challenge. So
yeah. Okay, good. Josh, how about you?
I spent last night catching up. I haven't done any of the PWM stuff yet, and haven't finished testing the current source because I'm still running with a 1K and a 3K resistor there. Yeah, when I first started, I opened up that power source page and just basically soldered everything from the page on in week 2. So got a few things to change. The MCP 3901 ended up, as I was saying earlier, went with the hot air and the solder paste, and that went on pretty easy. So all the pins are tested, but I haven't spoken to it yet. But yeah, pretty happy with that I've kept up. So.
Good. Margaret, how are you doing?
It was yesterday, huh? Okay. I'm actually pretty happy about stuff. I'm at the SPI. I tried using I have a SALE, I don't know how you pronounce it, logic analyzer that does SPI, and so I was using it to check the SPI traffic on the DAC, and it seemed to work okay. The thing I don't like about it's not real time. You have to sample and then play it back, but seemed to sort of work, and now I was just going to start on the Arduino. I was wondering, you do not put your Arduino code sketches into GitHub, is that correct?
Yeah, I haven't done that yet, actually. I figured people are going to be writing their own stuff, and probably better than mine. So there was some code, but I think you'd have to probably screen grab it.
Yeah, I was just wondering, no big deal one way or another. I was just wondering, because sometimes it's hard to see on the screen what you're doing, at least for me, with the granularity of the screen. But it's no big deal. Pretty easy to follow one way or the other.
Okay. Yeah, I'll try and push that in the future.
Yeah, no big deal.
Okay,
but
cool.
I'm getting very scared about this MCP thing, which is it's like the Loch Ness monster roaring its head around the lake of this thing. So
yeah,
interesting to see what you have to say.
Okay. James, you joined us. Why don't you jump in, tell us how you're doing and where you're at. Uh-oh. Don't think we have your sound, actually. Can anyone else hear James or no? No? Okay. All right, Wes, you're up, buddy. So Wes was on yesterday, but let's hear where Wes is at, too.
Yeah, so I've just been playing around with the 3901, trying to, get my Arduino talking to it and get some samples out. So that's been going reasonably well.
I saw your post about the 1 volt versus the half volt, right, for the full scale range because of the differential.
Yeah, and I'm not even sure that I read that right either. It looks like that the saturation for the 3901 might be at 3 times the VREF, which is actually less than 1 volt.
Okay.
So again, every time I read through that data sheet, I misunderstand it differently. So I'd be interested as you get there to sort of give some insight to clear up some of the confusion I've been having.
I find that a lot of times with AFE or ADC type of data sheets, even when you read it, it's like until you go and push a signal in, look at what you're getting and being like, actually you have to do a range of values, right? You have to do do a sweep or something and be like, okay, does this make sense? I had an ADC once where I thought I knew exactly what I was looking at. I had these numbers coming out, and then it turns out the whole thing was 2's complement, and I was just reading it all wrong to start with. So like the format of the number was wrong. It was just terrible. So anyways, yeah, it's going to be a playing between looking at the data sheet, analyzing it, and then also putting in some signals and making sure everything looks good on the input and the output. So James, you want to try again? Think you might have sound? No sound. All right, James will be a conscientious objector today. We do have the actually I can enable the Q&A box as well. So if people do have questions there, you can put them in. Oh, it's disabled. Ah, crud! I thought I had turned that on beforehand. Well, we do have the chat window over on the right side, so at least people, Josh, you can add stuff there. Not Josh, sorry, James. So you can add stuff there. Let's talk about well, actually, no, let's go straight to questions. Who's got a question? And whoever it is, just unmute real quick and you can start talking there. Try not to talk over one another.
I have a question about, remember when you were simulating the DAC and you put in a 0.1% on the 110 ohm resistor? It was pretty, might have been week 4.
So the 110 ohm resistor?
100 ohm and 10 ohm. So we used 2 so that we had the voltage divider.
Uh-huh. Oh, yeah, right.
And you said make sure to use a 0.4. I don't think you said make sure, but use the 0.1% ohm.
Right.
And I was wondering, we had more 1% ones. Was it very critical to use the 0.1%?
No, I don't remember why I said to use the 0.1% now, but really, yeah, there's no real reason. So you're talking about we set up a divider, right? We did a 9. It was coming back. Was that the one coming back from the adjustable regulator? Is that right, or is that something else?
It's the current source, isn't it?
Right. Okay. Yeah. So yeah, but the short answer is that no. The only place that the 0.1% resistors matter are in the instrumentation amp. I just thought we had more of those. That's why I had suggested that, I believe.
Oh, okay. All right. Thank you.
Mm-hmm. So James asked, ADC pins 12 and 13 connected to the 2x1 array. Where is this on the PCB? That's a good question. Actually, I have my schematic up here. So I can screen share it. I thought I could screen share it. That's weird. Maybe I can't screen share just that one screen. Oh, there it is. Okay, so start screen share. So we are pins 12 and 13 on the ADC. So this is the one I believe that we actually changed in situ on the fly rather, on the layout. I think what we did is we changed this. So this is listed as a 2x1 array here, but then if we open up the CV PCB, right, and that was, what was the, sorry, where did it go? Did that skip back? That's weird. Can you guys still see my screen okay? Yeah. Oh, I must have multiple windows open here. Something. Okay, there we go. So this is listed as P3. I think we changed P3 for the CV PCB. Or not. We did that somewhere here, though. So if I go back to here, and I share this guy, yeah. I believe in one of the layout videos we changed, yeah, you see right here, P3 got changed over to a capacitor. And I think that was because of it was a through hole. The one we chose was a through hole, right? It was very large, and because of the layout stuff, we wanted to change it over to a capacitor, just so that it was surface mount, right? So and we could do that same kind of thing here, where if we go edit parameters, you can do change modules, right? And we changed it to an SM0805 here. So I think that's where that happened. Does that answer your question?
Yeah, as far as I can tell for that, there's really no use we're going to have for either of those outputs right now.
Yeah, I was trying to remember what the I don't even remember what the MDAT 0 and 1 were.
They're alternative output streams of the sample data, I believe.
Oh, okay. Is that like a raw? I think that might be a raw from off the Sigma Delta, where you can actually get like stuff like that.
I believe so, yes.
Okay. Yeah. Yeah. So that's not a. We should be fine with what that is there. But yeah, that one was changed in situ, so that's why it doesn't look like a 2x1 array. Who else has questions?
Well, this is just an observation, but early on when I was testing my DAC, I hadn't yet started doing any serial port or serial debugging with Arduino SDK. I would just sort of plug it in, program it, unplug it, and test it out. And it seems like some folks have ran into some conflicts with pin 1 there being used as, well, it's either transmit or receive, I forget, but it's causing the fan bypass to kick in.
Yeah, that's the so I saw that post on the forum today. That is so pins 1 and 0 are TX and RX, and I think we actually started running out of pins then at that point. Right, if we go over to the Arduino, enter the sheet. So pins digital 0 and digital 1 are the TX and RX. That's the actual serial port. Gets doubled up. So when we're using fan mode or when we're doing serial stuff, it starts to turn on fan mode, so it can have some weird effects there. So now what we could do, I thought we had, I guess we don't have an extra pin here. So we could either try and, commandeer another pin here, or, maybe we could combine shutdown and reset and move fan mode up. Right, fan mode is the one. This is the one that goes over to the secondary large power MOSFET. Right, that actually disengages the sense resistor. And so I actually haven't populated that yet, so that's probably why this hasn't been a problem for me personally. But yeah, some people have put those in already. And so when you start doing serial stuff, it can flip that on. You can start having some weird current source behavior because you disengage your sense resistor.
Yeah, there's actually a bunch of pins there that we could use. Even might even be able to use the negative voltage adjust pin with the jumper wire over to there if we wanted. Since I don't believe we're going to be able to use that negative voltage adjust monitoring.
Oh yes, that's right. Yep. Yeah, so you're talking about the this one here. So these analog pins can double up as digital. Is that right?
I believe we might be able to do at least pulse width modulation with them. I would have to
Oh, that's
double
true.
check the data sheet though.
Yeah, I guess if you just wrote a 255 to it, that's a high, right? You just say analog right, and then in brackets you write 255, and that's the full scale value. So yeah, that would definitely work, especially if it was something for like a reset or something slow in the first place. I guess fan mode would be pretty slow as well. So we had kept the two, I guess this is analog 4 and 5, right? Those were kept open because that's the I2C bus in case we wanted to put a display shield on the top as well. And really, I think about that as well. If we did have a display shield, that could also work as a debug method, right? Instead of writing it out to the serial, now you just write it to the I2C, and that connects to a display shield. So that's another option as well going forward. But yeah, that is a good catch, though. I forget who caught that. So who's next? Fry, Josh, you guys got up early. I know you got to have some questions.
I wrote on my build log that using the serial output was adding a 25 millisecond delay. Just something to be aware of if you do have timing issues later on.
So just for the compiling, you mean? Yeah, just for having that.
No, well, I removed all my delays to try and get some cool pictures with the logic analyzer.
Mm-hmm.
And I noticed that if I left the serial print in, there'd be an extra 25 milliseconds between each packet on the SPI bus.
Oh, interesting. Okay.
Yeah.
It's because of the overhead for that.
Compared to if I removed the serial, the data would just pump out.
Did you try a faster baud rate?
I had it. I haven't at a faster baud rate, but it'll only lessen the impact. There'll still be extra delays.
Yeah.
So it's as I also noted, that it's in Alicia White's Making Embedded Systems book. She mentions it quite a bit, so that's why she loves her LEDs.
Oh, right. Yeah, I mean, there's always overhead, even when you're doing any kind of debugging or error reporting. So that is a good point. I don't think we're super time critical yet.
No.
But does that really make sense? Because SPI is a pretty fast bus.
Yeah, no, it's the event handling effectively inside the micro. So it has to switch tasks, and so it has a bunch of overhead associated with that. If it has to go, it's output something on the SPI bus. If you're slamming the SPI bus and you're saying give me as many readings out as you can, as fast as you can. If it has to go and then switch over to the serial port and read stuff or output stuff, then that starts to impact how many.
SPI far faster than the serial, and the event handling, the task switching should be exceptionally fast in comparison to those. So I was just wondering, is that really where the bottleneck is? You think? Because we're not doing that much SPI traffic.
Right. Well, Josh was testing how much he could output at once, though. So he was trying to get a bunch of packets in a row.
Okay.
Yeah, I was trying to on the logic analyzer have it so that I could watch it count up on that rather than having all of the data packets 1 second apart. So I'll paste the photo in the Hangout.
It was a vanity picture. Josh wanted a vanity picture on his logic analyzer, which is totally understandable.
Well, mine, you capture sample, and I guess, I've used it where you can put it in spreadsheets and stuff like that. I don't know
Hmm.
as a playback, but
Yeah.
yeah, that's usually why that I know that the logic analyzers has sampling instead of real time.
Okay. So, Josh, you had said that you were doing hot air. Did anyone get the MCP 3901? Wes, did you say you got it down without hot air?
I do have a hot air gun, and I had tried using that, but the rework that I did on it yesterday was just using a soldering iron, and I got it down great, actually.
Okay, awesome. And what about flux? Anyone else switch over to no clean flux? Is that a common thread with anyone else?
Yeah, definitely. I've been using some heavy duty stuff.
Yeah, the more rosin, the better. High solid count. Okay, Brian, I saw you unmuted before. Did you have a question or no?
I can't honestly remember now. I may as well say something about soldering it down. I have quite a nice little hoof type tip for my soldering iron, which really helps with the drag soldering.
Uh-huh.
So it's sort of a conical tip that's been cut at a slant, so it gives you a really nice surface
Oh,
to drag across the pins rather than something pointy. Um, so that's quite a nice little tool for doing this sort of work. So
so it's like
I
somewhere
got it.
between a conical and like a screwdriver tip or chisel tip.
I don't know if I'll actually be able to see it properly. I don't know if it will focus on it.
A little
No,
blurry.
not really. Yeah, I sort of can see how it's got a.
Yeah.
Anyway,
Right.
it's really nice for doing this sort of work. So
Okay. Okay, that's good.
I haven't really had any issue with any of the soldering so far. So it's been good.
Good, good. James wrote he had to use his workplace microscope, but other than that, did not cheat. James, were you the one that did who was doing the X-ray pictures too? Whoever was doing those X-ray pictures before were absolutely fantastic. I don't know like who has access to X-ray equipment, but I'm very jealous. And the pictures looked awesome too. You could see all the bond wires and everything. So. All right, so I started putting together stuff, and stuff that I'm doing today actually is kind of a wish list. We talked a little bit about this yesterday, the with the what else we need to get on order in order to for the last 2 weeks or however long this actually ends up taking, and so let me see. I have my list here somewhere. No, not that one. Here it is. So right now I have LEDs for testing the LED driver. Um, I actually never got that alternate LED driver, but then looking yesterday, the one that the Europeans needed to get, that actually is not available in the States. So Mauser has it in the list, but they don't have it in stock. And then various wires, so 22 gauge, 30 gauge wires, extra MCP 3901s in case I happen to break stuff. New sense resistors, because we talked about a little bit in the video for getting a variety of current outputs. So if we want to go lower current with more resolution, then we might want to get a higher sense resistor with more power rating, if you want to go higher current, then we need to change the sense resistor to a lower value, and we also need to change the PTC. I still need to get Arduino headers. I had some, but not a lot. So if we want to do stackable headers. Wes, you had mentioned yesterday the higher current inductors, that possibly the L2, L3, L4 might be the wrong rating. I'm going to probably pick up some MCP 48, is it 4811s and 4821s, the higher, the different precision, right? So you get the 10-bit and 12-bit versions have on hand. And then probably some solder paste and hot air reflow as well, just for future rework and stuff like that. James, I think we might be able to hear you now. James? I hear clicking.
Is that me?
Yeah, you're working now. All right. Welcome.
I didn't know that. Sorry.
That's okay. Well, let's hear how's your progress going?
You're breaking up. It's staccato sounding. It comes in bursts.
Oh, okay. Okay. Yeah, so that was I just read off the parts list of what I plan to get. Oh, and the other one is the oscillator that Wes had talked about as well. So that's another thing we need to have on the MCP 3901 in order to get the readings correct on the output as well. So any thoughts about that? Anyone have any thoughts about other things that need to be on the list, or anything else?
Hey, Chris, when you do the coding, and I think maybe Margaret mentioned this, if it'd be possible to maybe zoom in on your screen. I mean, I'm not going to type the same commands you're typing because that just doesn't work great over video. But just trying to even follow, it's pretty squinty over a laptop anyway, or an iPad.
Okay. So just yeah, the screen. I was trying to do the stuff for troubleshooting, to have the screen and then go back to the board. But maybe I just need to do a capture or something like that, and go back and forth.
Some of your earlier ones, it kind of was more zoomed in on the Arduino programming, and I could read it pretty well. But these more recent ones they're definitely a lot smaller.
Okay.
Thanks.
I am curious if anyone else has used any other tools for debugging the SPI protocol and stuff. I know that, well, I think someone may have mentioned that they had, but I was looking and that there's like the Bus Pirate, which I think is one of those dangerous prototype boards that look like it could be pretty handy, and I was just curious if anyone had used anything like that.
Looks like James has one right there. Yeah.
Is that the Bus Pirate?
That is the Bus Pirate, yeah. Yeah, so it's single command, I believe. I think it only does. I think you do one command at a time, but then you can script it so that it'll send out. It'll do multiple commands in a row, kind of thing. So and it'll do multiple protocols as well, not just SPI.
Okay.
There's also from Dangerous Prototypes the logic analyzer one as well.
Okay.
Which is probably better in situ than the Bus Pirate, which is more of a not really a protocol or bus analyzer. It's sort of like a prototyping tool where you just sort of chat to the object.
Oh, more like you just kind of ping it with commands, like one at a time. Versus.
Yeah, you can do that. You can sniff the buses a little bit too, but it's not as versatile as their logic sniffer. So they've made both tools, but both are very good.
Both pick based, right? I think they do a lot of pick stuff.
Yeah,
I'm not sure.
Oh, sorry. What I was saying, I'm using the, I guess it's Sally. Their names are weird, but they're lots of
Celia, that's how I say it, yeah.
I don't know whether they're going to switch your name, but so you put it on your USB, and I have the one with 8 channels, so you can do 2 SPIs at once, which is nice if you've got more than one chip using it. And then the output goes either on your Windows or your Mac. And I like that it decodes the SPI really nicely, so you can tell pretty easily what the traffic is, what the values are for the traffic going through, and you can actually read it back and see what protocol is going, what actually is being transmitted back and forth. And yeah, it supports multiple, like I2C and all the other ones. And a lot of folks on Arduino use that you do Arduino use that one I've seen. So that was the other reason. It's just a very easy one to use.
Personally, I've actually never, I never had an analyzer for it. And I've had like a mixed signal MSO scope in the past, but usually I just put it on the actual scope, like a multiple channel scope kind of thing. So
But can you read? Are you able to decode the packets with that? Does it understand SPI or anything? Or
I have my eyeballs.
I mean, it doesn't give you a hex.
No, I just do it manually.
Some of the newer scopes have the functionality to be able to decode different buses, like the Rigol 1074Z. That's an not even $800 scope that has 4 channels and can do some logic analyzer stuff as well.
Yeah, sometimes it recognizes it and does it automatically.
Yeah, I liked it because I used it one time for a wireless SPI, and what was nice is they had documented the SPI codes they had used and the data being sent, so you could just take the hex values coming through and see what traffic was being sent back and forth on the SPI, since it's at the programming level. So it was more like a programming interface, just looking at ones and zeros, which is nice.
Okay. So what other questions do we have?
I'm not close yet to the MCP 3901, but I'm completely intimidated from all the different mail going on. Any summaries or suggestions or thoughts from your own progress with that, or what you've seen on the build logs, or?
Build logs seem to be doing. I mean, usually most people it takes a try or two. The Tiptoe method seems like that's a pretty useful one. A lot of people did that. Pedro was on the call yesterday as well. And the thing that was interesting about that is he talked about, so usually the legs are kind of like this, right, on the normal part where they actually have a bend to them. And instead of actually going straight down, like I thought it was, they're actually still kind of curved in like this underneath the part. And so that's why that's a little different. I'm not sure if that was really shown in the build log. The flush cuts seem to work well for me. I don't know. I think other people might have tried that as well. And like I said, if I'm going to probably go over other hot air tools. Hot air is how I would if everything else being equal, if I would have been given this part on any other day, not doing the course or anything else like that, I would have done hot air. I mean, that's from the beginning, just because the pins are basically underneath the parts. At least in this bad configuration, if it had been the correct footprint from the beginning, then drag soldering would have been a more viable option. But all else being equal, I would have done hot air on my own board. Like on just a board I was doing on a regular day. So.
I got that book. I got that that AOUIEO when you talked about that you had with the hot air and the soldering and the all-in-one station.
Oh yeah, the AOU. Yeah.
It's really, really nice, and while the philosophy for folks like me that are novices, you could say, well, you should learn the hard way first, and I guess it's okay for a little bit. Then I kind of think, well, it's kind of like golf. I need a handicap. So that solder gun is just, the hot air is just awesome because in my mind you have another hand free that I didn't have free when I was soldering.
Yeah, I agree.
Take you so.
I agree. Okay, what other questions do we have?
Okay, I got one, Chris.
All right.
On the DAC, it mentions that you need a 10 microfarad cap. I bodged one on top of the circuit board. Right here, I use an electrolytic cap.
Okay.
To add that, I'm going to plan on taking it in Monday so I can use my expensive gear to see if it improves the noise figure. But has anybody else looked at the documentation of reducing noise on the DAC? I was thinking of throwing some extra ferrite beads too.
So your word, yeah, it was. I saw your post about this. That came from initial noise concerns. Is that right?
Yes, sir.
Yeah. I hadn't seen the 10 microfarad stuff. So we do have 10 mic. We could probably add in instead. But did the documentation say to use electrolytic specifically for the ESR or something like that?
It didn't mention. It was just something I had on hand that I cannibalized from something else.
Okay. Well, we do have that one spot. I mean, there is a 1 microfarad there. We have a similar size part that we can do a 10 microfarad, so that's an easy swap out. The bodge with a ferrite bead might be a little bit more difficult, but I don't remember what the noise profile actually looked like. Do you think someone linked you in the comments or to your build log rather? I'm pulling that up right now. Yeah. Output is quite noisy, and you said you botched. Yeah. So anytime someone says the output's noisy, usually my first thing is going to be to check your input rails as well, right? Often, especially with these DACs and everything else, I mean, it's going to shoot right through. Same with the op amp and everything else. So, did you happen to take a look at the rails at all, or?
No, that's something I'm gonna check out this Monday.
Okay. Yeah, and I think but the steps you're taking there are definitely the right ones. I mean, for even if it is the rails coming in, right? Sometimes you just can't deal with, there's nothing else you can do about the noise coming in. Definitely adding a ferrite bead in line, having more capacitance, bulk capacitance there should help to knock that down a little bit as well. So that is a good step.
Also on Wesley's trying to find the right caps for his crystal oscillator.
Mm-hmm.
He suggested 40 picofarads. That seems awfully high. Shouldn't you go much lower to whatever's specified for the crystal? Maybe 16 to 20 picofarads?
So the crystal that I got was a 20 picofarad load capacitance crystal, and based on that other site I linked, it seemed like you wanted to put capacitors that were about twice the load capacitance on each of the leads of it going to ground. I know nothing about crystals, so that was why I was basing my 40 picofarad statement on.
And then there's some gotchas for these ceramic caps. If you go into low voltage, the capacitance is not really at its rated value. It's actually lower.
There was an AVX data sheet about that, or no, that was the temperature-based one, where the capacitance started varying widely. How much difference in capacitance are you seeing?
Well, I haven't measured it yet. I got a real nice LCR meter at work, and I'm going to give it a shot.
Okay. Yeah, that actually would be really very useful and interesting information. So if you do end up measuring those, please let us know.
Okay.
Cool. And I'm glad your sound showed up. That's great.
I don't know what it was. It must have been squirrels on the telephone line or something.
We'll go with that. Yeah. Who else has questions? I'm here all day, folks.
Hey, I got one.
Okay.
Do you have a running list of corrections that need to be made, or is it just sort of stuck in your head?
So you mean for going forwards for like the next rev?
Yeah, and also the stuff that we kind of talked about. Is there, I don't know, can you have like a different blog that just, it's kind of an ongoing form where people could just add, like, I wish I had this
That's a good
feature.
idea. Yeah. So like a wish list blog basically, or a post, maybe just a post that could be sticky, that kind of thing?
Yeah.
Okay, that's a great idea. Yeah. Or a wish list. Yeah, definitely. That's a great idea. And then actually that could be a good way to. I was going to do a spreadsheet for the next rev stuff, but actually another sticky for the so wish list, or an error thread, and then also a next rev thread would be probably good. So
Maybe a wiki. That way your class could contribute.
yeah, me doing other website stuff might be a bad idea, but
No, you would just set it up. It would just be a wiki, and then your class could contribute.
No, I know. I'm saying, what do you think the bad part is the setting it up.
Oh, you need minions. You don't have any minions yet. What's up with that?
No, no minions. No minions yet. Yeah, we'll get there. Maybe someday. So yeah, we did talk about this. So like I said at the beginning of this, so Nathan and I said yesterday, what's up after the 8 week mark, and like I said, we're going to keep. So obviously you guys have access for life, so that includes the forums and everything else. So I mean, we can keep interacting on there as a way to interact project wise. But then I think also going forwards, with the Rev 2 and everything, going towards maybe a smaller board factor. Try and get that kind of thing, and then also designing it maybe for more of a case, because what I really think about is that this could be especially thinking with my travel case, this is an actual useful tool, right? A lot of the things that are in here could be very, very useful to have on the road with me. So I think that happened to be a really good coincidence.
Yeah, I would be interested in hearing from other folks, either on the forums or otherwise, about what do they envision using the bench buddy for, after the class, as a bench supply, or to do measurements, or
Yeah.
just something to showcase to their co-workers at work.
Yeah. Yeah, I don't know. My mind's going to my case, and I do plan to make other. I need to make other gear for my travel case as well. So other amplifiers and power supplies and stuff like that. So that'll be future fodder for contextual electronics, I'm sure.
Yeah, it sort of turns the corner to having an even more useful tool, especially as maybe not with this first session, but the next session, actually some software infrastructure that goes around it, that just sort of at the start with testing, you already have that whole infrastructure you can just sort of plug in, and maybe even the menu-driven thing that I believe Tom might be working on to sort of get to the next level of testing and applications for it.
Yeah, definitely. Brian, I saw you had unmuted. What's up?
Yeah, so on that front, I'm slowly working along sort of this bench buddy, but for Raspberry Pi.
Cool.
So that's sort of my applied learning as I learn bits, putting together the bench buddy with the Arduino. That I'm slowly doing all the layout work and bits for making one that fits on a Raspberry Pi.
Cool.
Which sort of gives you a more graphical way of interacting with it. And on that front, did you have a plan for sort of the connection for interacting with the sort of DAC and ADC features, and how we're sort of going to structure that going forward?
So you mean so for actually controlling it like at the same time kind of thing?
Yeah.
No plan. Yeah, no. The important thing was kind of getting to the part where the hardware works. But that is interesting, because one of the plans from the beginning was, like I said, that I2C based display. So and that same board, I forget there was one from Adafruit, and I think there's another one out there. Basically, it has a screen. It's like a 2x16 or 4x16 LCD, but then there's also buttons on board, so you could actually go through menus, and effectively it would take the same kind of approach, kind of like what Gabe did with the X Mini Lab type of thing. So having a screen for output, but then also being able to interact with menus, and that kind of like what Tommy is doing. So that kind of thing.
Yeah, they have a number of nice little OLED screens that you can just chuck on the SPI bus as well.
Oh, interesting. Yeah, I'm not sure how that would work with all the that actually would be a interesting practical test as well, because when you start getting up in terms of total number of things on the SPI bus, then you start having to give priority, right? So do you update the screen, or do you go take another reading from the ADC, right? You don't want your screen update to actually hurt your measurement stuff, right? And that starts to get into a lot of measurement platforms that I've worked on. Usually they're completely separate units, so it is, offloading it's usually a good idea to something else.
Yeah, definitely. Well, that's when you get into you push the button and screen doesn't update and it samples for a while, then comes back to you.
Right. Yeah. Well, that'll be interesting to see your Raspberry Pi thing as well. I had also envisioned, doing something with BeagleBone Black at some point as well. I think that's another platform that'd be good, to kind of move towards this. But that's, first things first, right?
Yeah, definitely. Like, I sort of want it as a sort of platform for teaching kids, because you can have the sort of a whole environment built up around the Raspberry Pi, and sort of graphical, nice way of controlling it, and they can do Arduino coding and sort of as a learning platform for digital electronics. It should come together quite nicely. So.
Cool.
So along that front, Chris, what are your thoughts on maybe in the future, instead of having it actually plug into the Arduino, you just put some cable headers there, and then that would allow maybe even some flexibility for the same board. You could just, split the wires up and plug them into the Raspberry Pi one way or the Arduino another.
Can you explain that a little bit more? I'm not sure I quite understand.
Well, so today we actually, plug the board directly into the Arduino, but you could very easily have just had a cable there to split. Right, and so now the two boards sit side by side rather than stacked, but because you have that cable, you could then sort of, tear the wires apart and put on different jumpers of, a different, microprocessor.
Right. So it'd be like taking the bench buddy and lopping off. Well, I guess it'd be lopping off the middle, because you need the ATX in there somehow, or some kind of power source as well. But
well, yeah, you could lop it off to actually reduce the footprint, but there'd be a header there that breaks out all the Arduino pins we care about that need to be controlled by a micro.
Right. That's very interesting. And actually, I'm interested in Bry's idea too, because going platform to platform as well, there are different offerings, of course, right? We even have seen this between the Uno and the Leonardo, right? These are Arduino platforms that are slightly different board to board. So, kind of what we could do with each one, right? There would be probably trade-offs in terms of, could you do all the same functionality? And that kind of gets into more of an interesting exercise in modularity and everything else, right? How do you define your signal interfaces so that you can cover the most amount of platforms without limiting on certain ones?
Yeah, you mean getting some flexibility maybe and being able to move to different pins if one's used for something else or there's a conflict, but you might get into the category of having to deal with logic shifters if the voltage rails of one platform was not 5 volts but 3.5 volts. So there's other things that come into play.
Yeah, that is interesting, because that would definitely shrink down the, for a Rev 2, right? I mean, right now it's 15 square inches. If we could get rid of the Arduino, that's like probably half of that, right? So kind of just crush everything together at that point, and then just a header there. So yeah, that's definitely a good idea going forwards. And maybe we after the board's up and running to a sufficient point, we could start aggregating into teams and start slicing. I mean, because it doesn't have to be one way or another, right? It could be different flavors and see what works, and kind of recongregate after that kind of thing. Have reunions,
Definitely.
Yeah.
So why does everybody want to do Raspberry Pi? Just curious.
Well, like Bryce said, it's it's a very graphically strong platform. So if you wanted to have nice visualizations of your data, you could start using a lot of the built-in libraries for graphing and display and stuff like that.
Yeah, so I guess for graphing and for internet, it'd be much better than Arduino for the most part.
Oh, way better.
Arduino has trouble with internet, like it doesn't do HTTPS, and etc. So, but then for what we have right now, it's probably overkill.
Possibly, yeah.
But the graphing would be nice. Bri brings a really good point. Although there's graphing libraries on the Arduino platform. Another way you can handle it, and this isn't real time, is just write them out into CSV format, and then put that into a Google spreadsheet or what have you.
Right. That's a little bit more of a top-heavy approach where you need a computer attached, though. I think the idea is you can go kind of mobile with a Raspberry Pi or a BeagleBone or something.
Yeah, what I like about that though is it's easy to send a file from Arduino to, like, say, a Google. Well, it's not easy to all the time, but you can send it up to a web server, and then since it's in CSV, you can just open it up into one of the Google apps or what have you, and then have all the charting done for you without having to make a custom charting app. Just use anyone that's out there.
Cool.
Raspberry Pi would be
I mean,
interesting too. Raspberry Pi would be interesting too because you'd have to deal with all the I/O issues. I'm assuming because I think Raspberry Pi has how many I/O pins? Is it like 8 or 10?
26, but there's limited libraries, I think. There,
Raspberry
Brian,
Pi has 26 pins.
Brian would probably know better than I would. I don't know.
I thought Raspberry Pi had a lot less I/O pins.
It doesn't have a lot of I/O pins, and probably that's not limiting though, because you can get breakouts and you can mux them and stuff.
That would.
The main,
Yep, that would. Go ahead.
The main issue with Raspberry Pi is since you're running a full operating system, you can't do stuff as fast as you can on a micro. So I'm unsure yet whether I'll have to add a little ATtiny for some functionality or not. The reason that I'm using Raspberry Pi rather than something like the BeagleBone or one of those is this is sort of an existing project and it already has the Raspberry Pi. And through the course of this, it's like this, because it's sort of an environment that gives you a little portable workstation for programming Arduinos and other like sort of basic education tasks, and just had a fixed output power supply before. But with all the things that I've learned from doing this course so far, it'd be really nice to add all these features and then tie that back in to a way that's very simple to interact with. So that's sort of where I'm going and why. It's not, if I was building this, I would choose the Raspberry Pi. I have a Raspberry Pi, and I'd like to tie it together with the functionality that the BenchBuddy brings. Cool. Without the cost of an Arduino.
It's great to hear how people are actually using some of this stuff. That's kind of why I asked. I never, because I hear a lot of the different ones, and I'm not sure what everybody's doing. So it's thanks for letting us know.
So starting to wrap up here. Do we have any other questions before we wrap up? Okay. Well, we will have a couple more Hangouts. Obviously, there's more videos to be had. There's more stuff to be done. But I think it's going pretty well. I mean, there was some concern that we're kind of getting down to the end of our time. But like I mentioned, we'll keep going, and we'll be able to break up into task forces and develop new bench buddies for the future. I think we'll have to come up with new names for the flavors of them, though. Bench Buddy Lite, Bench Buddy Pro, Bench Buddy, I don't know, Diet Bench Buddy, or something, a better name in the first place. All right, well, thanks everybody for showing up today, and we'll talk to you next week.
Thank you.
I see you, Chris.
Thanks, Chris.
Thanks, Chris.